All right, that's the end of our subsession. So we are going to get those 3 speakers plus our NIH representative up here on stage for the panel. And while they're mobilizing, I just have a quick question for Robert, which is you mentioned the cost of getting your methods onto the cloud. And I just wondered if you'd heard of the NIH Strides program that tries to help NIH researchers with cloud computing costs.
Yes. Is this microphone on? Yeah, so I was able to get access to the LLMs through the NIH Strides program, and then also through some additional funding from our Office of Data Science and our Office of Scientific Computing. But yes, not only can you get access through NIH through the Strides program, they have just recently been getting a big push behind the Cloud Lab program, which gives you 90 days to evaluate any of the cloud providers, and they give you $500 worth of credit. So this is for like the end researchers and scientists to get to try those as well.
Great. All right. Thanks. Does anyone from the audience have a question for the panel? If not, I'll kick things off with a question to all of you about what were the biggest challenges that you encountered when trying to get your stuff running on the cloud, and what were some of the learnings that you took away from getting those to work?
You first. Yeah, you're working with a much larger data set.
Well, we is this on?
Yes.
Okay.
Yeah.
Yeah, well, we are working with a much larger data set. I'm not sure how much I can speak to working specifically with the cloud, but you really do need to be prepared for a lot of false starts.
Yeah, a lot of the difficulty in utilizing the large language models to do this type of work is just from the implementation, the technological implementation. Where are you storing your data? How are you getting access to the models? How are you doing evaluations? So it took me 1.5 years to get all of the infrastructure set up to begin doing the science. And that's also just because this is a nascent field. And I've been following the trends and trying to keep up with how fast things are moving to be able to deploy stuff.
Yeah, so as the PI of the lab, I can add on what Trey mentioned. I'm not the person who actually do this work. I find it's very difficult to find capable students and postdoc to work on this. As Trey mentioned, that this is pretty new stuff. I'm wondering, are there any, NIH program or other funding agencies that can support those kind of training or education, working together with, cloud computing service provider, to train, the next generation researchers, students to, learn those necessary skills to use, cloud computing in their research.
I can just share a little bit of personal experience on this one that I know. I know NIH is interested, though I can't speak for NIH technically, is interested in looking at this issue of making sure that people are trained. I know that's part of what Cloud Lab is for, is to get through the barrier that I had as a graduate student. I only got my PhD in 2016, and even I did not get much cloud training whatsoever. And so as it was starting to come in, I was terrified, because I was like, well, if I start playing with that, I'm going to spend $50,000 by accident. Right. And so it's nice that it's starting to be things like Cloud Lab, like these sandboxes. They're like, please come play, and we will have guardrails that will keep you from hurting yourself. And you can learn how to actually implement this stuff. Now, going from that scale to the kind of data that you all were working with, that's a different step. But that first barrier of, I'm afraid I'm going to break it, is like where a lot of people were with personal computers in the first 1990s and late 80s. If I hit this button, is it going to explode? Right. So I think having some low bar entry to get past that is where we're at.
Just to speak to that really briefly. So yes, we have access to Cloud Lab and stuff, but the nice thing about the current open source movement in LLMs is that it's possible to deploy like a 7 billion parameter model like Llama 3 on a consumer grade GPU and do your embeddings on there. And so there are options to like experiment on a smaller scale before you even try to go to deploy cloud stuff. But in all of that, you still have that technical hurdle that you have to overcome of being able to use these technologies before you can do the science. So.
Okay, thanks. We have a question from the audience.
Hi, my name is Jeffrey Bloodworth. I'm from Indiana University. There's a lot of concern in the media about plagiarism. We're using these text mining models, and we're sourcing all these people and not giving credit to where it's due. And so I'm wondering how, since you guys are scientists and you're designing this stuff for scientists, right? How are you guys incorporating this, pulling the source and giving that to us as an output whenever we go in and submit a query? Are we getting the sources both for provenance sake and for my sanity check so that I can go and check, where's this information coming from? Is that being implemented into the software that you guys are building?
Okay, yeah, I can answer this one definitely. Yes, as far as I know, there is nothing our team does that does not involve locating the source. Every API in PubData, for example, will return the source, because without the source, you can't evaluate the information. It may take 2 queries to get it, but yes, you will absolutely get that. And it's worth noting, at least as far as what a lot of the text mining work that we've done so far, there's a big difference between the extraction type work and the generative work, right? The extraction work.
Next door.
I didn't think that was such an insightful comment. The extraction work, absolutely. We return the PubMed ID, for example, where we found this, and that sort of thing. And the annotations are paragraph by paragraph across the entire document. Whereas generative, it's very difficult to get it to do that. And that was actually part of the reason why we tried using the PubData as a retrieval augmented generation to see if we could get it to actually tell you where it found the information.
Yeah, and as part of our web interface, we are taking that into account and trying to provide sources as well. So as part of the retrieval augmented generation pipeline, it will actually put into the context of the prompt where the information came from for each data source. And then, you have to do a little bit of post-processing to make sure that that's linked up in the output of the prompt. But yes, we are trying to use sources like PubMed and Semantic Scholar to show where the data is coming from and hopefully give you a link you can actually click and look for yourself. So,
I'm not sure if I go to answer the question because I don't work on text mining or PubMed literature mining. So for our work, we just implement our websites on AWS. There's one problem is that user submit their unpublished genome sequencing data to our standalone computer server to AWS. I found that AWS is extremely secure in that aspect. For our standalone server, always worried about the bot attack to our computer, get access to the user submitted data. Of course, there are some security implementation can prevent that, but AWS or other cloud computing, they did a very good job to protect the data privacy.
So a big part of my job is supporting various fair data efforts around the biomedical and behavioral health works search space. And I can tell you right now, I almost want to push your question back one level, which is, can the data tell the model where the data came from? And if it can't, then asking the model to be transparent is a little bit difficult. So I think part of this and a big key to it is going to be adopting, getting communities together, solving the social problem to get good metadata on data, whether it's text data or anything else. Because without that metadata, without that discoverability, without the interoperability, it's going to be hard for the model to cite itself if the data can't cite itself.
I just wanted to follow up on that and say one way to address that particular issue is by giving the metadata to the retrieval augmented generation pipelines. So LibreChat, I'm sorry, not LibreChat, Llama Index, so many new terms with generative AI stuff. Llama Index has a directed acyclic graph and like property parsing ingesters that you can use to grab the metadata from the data and feed that in as well. So there are efforts to try and address that issue by looking at the metadata as well. So.
Okay, thank you. Do we have another audience question? Yes.
Thank you. Two quick questions. So I guess the first one is, do you notice any changes in how early in systems development people are using the cloud? So there's a lot of examples of people developing something off cloud, realizing they need to scale and then migrating it. I guess if you're seeing a growth in cloud first for smaller systems because people are anticipating this, or if that's still not common practice. And then the second thing is, how are people addressing vendor lock-in? Because of course there's a big deal with going with AWS or Azure or whatever else. And how do you sort of manage the risks there?
I can answer that. So the goal of TalksPipe from the beginning has been to try and keep everything as open source as possible so that it can be used by other NIH agencies and other organizations. From my efforts, by using stuff like LibreChat, that's MIT open source, Llama Index, et cetera, that takes care of the majority of keeping things from having vendor lock-in. And the nice thing about the large language models is even though OpenAI and Anthropic have these top class models, a light LLM, the proxy, turns everything into an OpenAI API call, and which is becoming more and more compatible with most LLMs. So I can basically just go in and change which model is being called. So that's one way to avoid like lock-in in terms of the models. In terms of the actual like data and stuff, trying to use open source and accessible APIs and data sets is another way to avoid lock-in. But when you get to a certain point of a large enough data set, it's unavoidable that you're going to have to figure out where that's being stored, how you're querying it, how you're serving it to your users. So I'll let him speak to how they're managing as much data as they are for all of PubMed and scraping that. But for the smaller data set stuff, there are ways to try and keep it as open as possible, which is our goal. I definitely want this product to be able to be just spun up and used by researchers in general. So
that vendor lock-in is a problem that we are very aware of at NIH. So because of that, there are some efforts among the large programs at NIH for cross-platform interoperability. So we are trying to find ways of how we can make the major cloud providers to be interoperable with each other. So there is some effort going on that. So.
As far as for myself, I'm not sure I have a really good answer for you on the vendor lock-in because it's a real issue. One thing we tend to do is we will work on the cloud, but we also work with the local high performance computing resources, and tend to use the cloud more for bursty type work. One of the biggest things I've noted though is that certainly with text mining, if you want to work with large language models, there becomes a point where you really can't run it locally. There's just no way to do it. And so, for us, if we want to run anything much bigger than Llama, you're just going to have to use it on the cloud. You don't have a choice. So you got to start there.
Okay, thanks. Well, we have 2 minutes left. I just have one final question that we can answer as time permits, which is, so now that you've been funded by the NIH to do this cloud-based work, do you have any advice for the NIH as they work on future funding opportunities? Like, is there something that would have helped or that you can suggest for these future funding calls?
Yeah, I will say Cloud Lab is a great initiative for getting researchers the resources they need to start trying to play with these sorts of tools. There are still options, like you said, to use it on, say, our BioWolf supercomputer, where you can spin up an interactive GPU, VM server and spin up models there and play with them as well. That's a great way to. There's a lot of cross compatibility and skills with spinning up something on BioWolf and deploying to the cloud. You need to know a lot of the same stuff. So there are ways to allow researchers access to these tools. I would definitely say Cloud Lab is a step in the right direction, and we should keep pushing down that front. Past that, just being able to give researchers an API key that they can call and not having to force them to go through that whole setup of getting a cloud instance spun up or getting access to the models. would be the next like really good step to get researchers direct access to trying these things out, in my opinion.
I just want to add that in the slide, Huluk gave, so there is one funding opportunity that was just published early this year. Also, that can be applicable to that's applicable to many funding mechanisms. So if people have active parent award, currently funded by NIH, they should definitely look into that. It's just
Great.
for the supplement to help to explore cloud.
Thanks. That's a great tip.
Can
I
add
think,
something else?
yeah, sure.
So actually, part of STRICE agreement with the cloud providers was that the companies were going to provide training and help support for the users. So we are not sure how much of the user community is taking advantage of that training offer. So in that case, like if you know folks that want to get involved with the cloud computing, please encourage them to work with the cloud providers. As part of STRICE, they are offering training and help. So please let that information spread to the community. We'll appreciate that.
The Microsoft website has actually very good training documentation for working with the language models and all the different processes. So I think that in terms of free and available training, their documentation is probably one of the better that I've seen so far. So
Yes, others are Google and AWS are doing the same thing too.
Okay. We need to wrap up.